Hi everyone. My name is Anuj Vaishampayan, and I'm currently working as a principal architect in Salesforce industry. And today's session is all about enterprise product catalog best practices for Salesforce industries. Uh, so before beginning, I would like to thanks Apex Hours for providing the opportunity for delivering this session. So thank you. So forward-looking statement first, general any product purchasing decision should be made based on the product generally available and not based on the product roadmap. Quick introduction about me. My name is Anuj Vaishampayani, and I am currently based in Singapore. I have around 4 years of experience with Comms Cloud and more than 13 years of experience in our telco industry. During my time in Velocity and Salesforce, I've been involved in 10 plus communication cloud implementation across EMEA and APAC regions. I have a total experience of around 15 plus telco BSS OSS implementation across the globe. I have also experience working with multiple BSS OSS providers like MDocs, Nutcracker, and Sigma. I've been contributing actively to Comms Cloud AP exams, preparations, and content development and also industry CPQ developer credential exams. I have recently acquired a certification for accredited communication cloud professional. I'm a ranger. Outside of work, I like to travel and photography. So this session is all about on product modeling best practices, what benefits you can get it. So normally there is a definition, when products, a product basically define a company, and company generates value through products. Customers pays for the value from the products. So this is really important to get your products aligned and optimized and simplified so that you can generate more value out of it, right? This is a topic I see, widely ignored or, taken lightly across several, comms cloud implementation, and uh, then it results into, several performance and scalable performance issues, scalability issues across, the ISPs. So it is really important to get your product modeling correct with following best practices. So this is a centerpiece of your comms cloud implementation. So you should be really focusing first on having your product modeling right and simplified, optimized so that it is aligned across multiple modules like CPQ, order management. Okay, what benefits you get by following these best practices is you can launch your product in your time to market window basically reduce. You have cost reduction, you have flexibility to create new offers, promotions. Differentiate in market by using right pricing, promotion strategies, quickly introducing these pricing changes, and minimize proliferation and specifications by inheritance and reuse of multi components. Why optimize? Very important question. As you all know that Salesforce has a multi-tenant architecture, uh, and in this multi-tenant architecture you have you know uh, a dedicated space for your application or uh, for you running your applications. uh, and this basically you can understand this by having an example of a building consisting of multiple tenants, and uh, all the tenants basically they shared resources like power, water, and building maintenance. So similar to this example, Salesforce also works on multi-tenant architecture, and you have your dedicated space on this multi-tenant architecture where resources are shared. So you have to be, your solutions, your implementations have to be optimized enough so that they don't utilize, heavy resources. Otherwise, you will have, a lot of issues with your performance and scalabilities. What factors goes into, performance? Basically, you have uh, multi-tenant architecture, your platform governor limits, triggers, workflow, backend systems, network, what type of data shapes you are using, what type of data size, indexes, SFI implementations, how complex your SFI implementation is there any other managed package installed on your org? Is there any, you have heavily customized your solution? Are there any customizations on the platform? Then at last your config settings, what type of configurations you have put for your SFI settings, your for caching mechanisms, for your matrices. So all these factors contribute to performance. What is the importance of product catalog? Basically, uh, I have seen many examples across several implementation that uh, the importance of product catalog is ignored, and before even discussing the product catalog or product modeling topics, uh, people tend to start developing their CPQ order management solution, and without even caring that how the product modeling will impact. And when they realize it, the time would be really pass, and you won't have time to basically react on the changes, because you are half through your project, and you have created just based on the requirements. You have just created a product and not even given a thought on optimizing or simplifying the product, and you have just followed the requirements, created the products, and move ahead with your implementation, development of your guided selling or order management, which will cause lot of issues, have caused lot of issues across lot of implementations. And when when come to know to this performance factor, which is heavily dependent on how you model your products, this would be really late in the project implementation phase. So it is really important to get your product modeling designed first, considering all your factors of CPQ, order management, and other modules which are interacting with product models. Because in SFI Comms Cloud, all other applications revolve around your product catalog. If your product catalog is not sorted, all your applications will have issues. Because SFI, the SFI solution basically works on using centralized product catalog or centralized enterprise product catalog. All solutions revolves around product catalog. So it is very important to focus on your designing of your product catalog first, and then move on to develop your CPQ order management solution. So why use an enterprise product catalog? Product catalog is a key building block in any sales journey. Uh, SFI, basically SFI EPC contains all commercial product information that enables product managers to define and map new product offerings. It contains technical information that enables fulfillment managers to define and map the required order fulfillment process by creating your technical products, commercial products. It is used by other modules like CPQ, digital commerce, and order management. You perform your product design, pricing, product lifecycle management, product versioning, and product publishing inside the enterprise catalog. So how does this enterprise product catalog looks like? There are two aspects of it. One is a commercial product catalog, and another is technical product catalog. And in between this, there is a there is an entity called product spec sitting, which is tying this commercial and technical product catalog together. So what is commercial product? Commercial product basically is nothing but a offering or a product offer available for sale, what actually customer sees and buys. And technical product catalog basically holds all your technical products which used by your backend system, such as provisioning systems, or any other downstream system where all technical information is needed for provisioning those services, and those information is relevant to the customer. So combining all key modules, EPC, CPQ, and order management basically enables you to runs your business with agility. So process starts from defining your products from in EPC, your product CFS, RFS, your pricing, your commercial product, technical products you have to define in EPC. Then these offerings, these entities will be used by CPQ throughout your guided selling, or CPQ card, or your digital commerce APIs, and you will submit your orders via CPQ APIs or hybrid card. Then these orders will end up into order management system, uh, where it will be followed by running the orchestration plan to start sending these orders to fulfillment systems. So commercial and technical catalogs. What is this commercial and technical catalog, and why it is important to define these two catalogs separately? As I was explaining before, you should approach the product modeling by separating two aspects of the product. That is, one side commercial and technical. You should always define two catalogs in the system, one which will hold all the commercial offerings, another which will hold all your technical products, which in turns hold all your technical specifications, technical information which needs to be sent down to provisioning systems. Why it is important to define this catalog separately, you know to avoid loading unnecessary technical information into the CPQ card, which is not required by the customer. So basically, in comms cloud implementations, you have an option to capture all this information in form of attributes on the product. But you have to ask the question first whether it is necessary to hold all the information on the commercial product, or we can separate this information into aspect one which is totally relevant to the customers which are actually buying the product, and what information needed for providing this service to customer, and what information needs to be sent to provisioning system. That's why it is, very important to separate these two entities for your products into commercial and technical catalogs to avoid having deep hierarchies into bundle, having a lot of attribute configurations to capture only technical information on the commercial side. And it will basically defining this, separating these two catalogs will give you ease of managing these products separately. So commercial product managers can manage their commercial product separately without worrying of what technical changes they it would lead to. And then technical product managers can manage the information, what information is needed for the downstream system, so that they can have configured their technical products accordingly. And there is a huge benefit in terms of performance, because you are separating this catalog, you are separating these two information, and you are not loading or making your products heavy with putting all this information on the commercial side. It will help the APIs to load data faster and improve the performance of CPQ. So here is an example of how commercial catalog example. I try to put it into simple example of basically a restaurant menu or a fast food joint menu. So you can see that what commercial products are there. So there are chicken. What you see is a product which you are going to buy. You don't care about what goes into in this product. You see a picture, you like it, you like the taste, and you want to go according to your taste, and you buy the meal, or buy your burger or pizza or any uh, chicken mix based on your liking, right? And how you understand the product. Similarly, in telco world also, a commercial offering would, when you present these products to customer, it should have only relevant information which is necessary for customer to know that product, right? So that it should be simple to understand, easy to buy, and should not be heavily loaded with the information, because customer doesn't care what goes in the backend system. He or she will come to just see the product, what benefits he or she will get into that product, and then the customers will make the decision based on the characteristics of the product. So now you have seen the example of commercial product. Now, what goes behind the scene? It goes into a technical catalog example. So, taking an example of spicy chicken tortilla wrap. This was my commercial product, but when you go into the what type of ingredients, what this tortilla is made of. Basically, you can you see the ingredients. There are several ingredients put into it. There are instructions how to cook it, what is needed, and how, what temperature, how it is cooked. So all this information is not relevant to customer, right? He just want to eat, or she just want to eat the tortilla chicken wrap, right? And he doesn't care about what ingredients are made of. Majorly, they know it's a chicken wrap, right? But what it is made of, what type of ingredients are there, how many ingredients are there, customer doesn't care, right? And this is why this information is not relevant to customer. You should not present it to the customer. It should be in your cooking menu, or it should be in your cooking instruction. Similarly, for in telco, when you are selling a mobile plan or a broadband plan, it should be very minimal information. Commercial relevant information should be put on the commercial product, and all provisioning related information, technical information, should be configured inside the technical catalog. So let's take a broadband product example. How basically broadband what type of broadband are there and how broadband offers are there in the market. Uh, so if you see this diagram, there is an exchange, a local ISP provider which provides internet. There could be two separate kind of connections. One could be copper, one is traditional fiber, and there is a direct line which coming from the exchange directly to a house which is a full fiber. Okay, so these are the access types which is provided by the ISPs. And let's now look into the offers, how a commercial offer looks like for a fiber. So here you could see there are, four plans: fiber 150, full fiber, fiber 500, fiber 900, and fiber 65. And what information is necessary for customers to read? Basically, customer wants to know what is the price of this plan, how long the contract is, what type of discount he's getting, what is the speed of this, right? So all this information is necessary for the commercial offering, and that's how for each majorly you will see all similar information across telcos in the world. uh, Pricing, speed, accessories provided under this plan, and discounts and contracts. So how broadband order fulfillment looks like, what type of stages it goes to. So basically, order fulfillment involve it's typically a complex process, involving number of tasks, various tasks involved in. So for a broadband order fulfillment, what is needed, you need to create, you need to check the inventory. If you are delivering any hardware with your broadband plan, such as router, modem, then you have to inform the billing system to activate the billing. You have to it goes into assurance process, then it goes into your hard. If there is any modem router involved, it goes into delivery. It goes into then into your provisioning of your what type of access you are having, fiber, what type of speed you will have. Uh, so majorly you will see, in communication industry, there are three types of catalogs available: commercial, functional, and technical. But widely there would be there you will see only differentiation between commercial and technical product catalog. Functional is in terms of just concepts. Uh, so in commercial catalog, only as I was explaining that you will have only commercial characteristics defined on your offers, which is relevant for the customers, right? uh, then on the functional catalog, basically you can say it's kind of a CFS, customer facing specification, or customer facing resource. uh, So product specification basically, it doesn't describe any commercial characteristics. Only functional capabilities and characteristics are defined on the product spec. On Similarly, for like it's kind of a CFS. I am sure if anyone is not aware of CFS and RFS, just giving you a short description. CFS is customer facing sources, and RFS is resource facing services. Customer facing services and resource facing services. So uh, basically on customer facing side, it's it doesn't needs to hold your characteristics, technical characteristics. Only functional and capabilities and characteristics are there. S- and Now we go to technical solution, or technical or RFS, resource tracing. So it basically will have only your technical characteristics, like what type of access you need. Is there any, IP address, static IP, or any, IP address needs to be assigned, or any, for broadband, there could be several characteristics, several technical information, what type of technology it is being, service capabilities, which is not uh, need to know by the customer, but relevant for the downstream system. So all these informations would be captured under the RFS, or under the technical catalog. So uh, you might come across on the situations where you will have the requirements from different stakeholders for product modeling, right? Each probably product manager, or each manager will come, or different stakeholder will come and say, hey, I have this requirement, and can you configure according to my requirement, right? So there's I should say there is no simple one size which would satisfy all the requirements, for all the customers. So we have to find a balance between all these stakeholders, and uh, have your optimized model defined considering your commercial and technical catalog, and also compromises, also satisfy the requirements for the all these stakeholders. So so someone front end manager will come and say, hey, I want the front end to display products in a certain way. Then fulfillment manager will come that I want this information into the downstream system. Billing managers will say that I want to bill products in a certain way. So if you go and consider each of these requirements, and define the products as for the stakeholders needs, then you will probably land up into you know a big product model, or deep hierarchical product model, which will have issues, or very complex product model which will have issues in future. So product catalog definition, basically, as I was explaining on the previous slide, that no model will fits all, or no model will satisfy, could be able to satisfy all the requirements raised by the stakeholder. So lack of agreement across different business functions on the ideal product model, it is due to the purpose that the product catalog serves in enterprise BSS OSS. Like, it is constraint optimization problem and requires trade-offs to be made. Okay, so this is basically a diagram depicting that each module is, or each stakeholder is uh, raising the requirement to be modeled as in a certain way, products to be modeled in a certain way. uh, in yellow you can say there is optimal product model for CPQ. Then in red, you can see optimal product model for OM, and in green, you can see there is a product model for which is acceptable by operation and maintenance. So all these upper so all combining to this, there was a where you could see the intersection happens, a particular model that was chosen based on the product requirements, project requirements. So, and how far this product is from the optimal model per domain. So basically, you have to have a balance, like I was explaining, between these stakeholders, and configure your product model which is optimized for for the system, for balancing the end-to-end system and not only for particular module. So I just put an example of a product model which was not following the best practices. You could see this is an example of a Comms Cloud implementation in Europe, where you have they have created an offering for fiber broadband, and you could see how deep the hierarchy is, and you can see how like number of products are there under a bundle. So whenever you are trying to add this bundle, all these products are fetched from the catalog, added to the cart, or to the basket. You can imagine having these number of line items in a single call could load the API. It will have several degradation in your performance of CPQ. It will cause lot of problems in running rules. Basically you will end up into lot of issues if you go and define your model product model like this. So we have to be very careful on when we go on product modeling journey. So how you should approach basically a product model solution. You have to see if there are multiple solution options available. Based on the requirement, first gather your requirements and see based on the requirements if you can configure your products, or you have multiple solution or multiple patterns of the product. Just define them all initially. During the design time, you should design, considering all the options, define all your options for product modeling, list your pros and cons for each option. Also, it, there is a great way to prove which product model is best for your business. Basically run POCs. Have evaluate your pros and cons for each model. Run POCs, run an order with by using all these product modeling options, and then consider their pros and cons, what benefits you get for each model, what disadvantages have over one over another model, right? Define your selection criteria. What is basically what would be your selection criteria to choose an optimal model or best model? Score your criteria against each option, right? So you will list down your pros and cons, you will have your selection criteria, then you have to score all your product option, product modeling option, and for based on the selection criteria, and then basically summarize your results, right? Summarize the result for each option you have modeled for, and after defining all this, review your options with your stakeholder, and knowledgeable reviewer, experienced reviewers who have their experience in product modeling and with the telco business holders, and provide the recommendation. Inform all your key stakeholders to get consensus and buy-in for the preferred option. So this is really an important point. So you should present all these options, what you have gone through, what are your POC results, what are your pros and cons. You should all the informations you should collect and present it to the stakeholders, and with your recommendation have their consensus, or have their agreement on choosing the preferred option. Simplify. Why simplify? Why I'm making an emphasis on simplifying the product model is really important, because if you go into digital transformation efforts, any digital transformation project, you have to go and rather adopting the product model as is. You should, try to simplify and optimize as much as possible. You should go with the mindset that we have to simplify. You should assume that there could be issues with the existing product model or legacy product modeling. There could be a complexities, there would be issues. So how we can simplify, even when you are going into greenfield project where there is no legacy system, you should always focus on simplifying and keeping your product model very simple, which will help in basically scaling your product, scaling your solution in future as well, right? So what it will give you, you know basically it will give you the agility, it will provide you the business value, it will have the efficiency in your whole digital transformation program. Rationalize products and try to aim for reuse instead of creating multiple permutation combinations for each product, similar products. Try to rationalize it and have it, if there are like n number of variants for the same product, try to rationalize it, try to use attribute based modeling, try to reduce the number of products in the catalog and rationalize it. Ask your business stakeholders whether all these products are necessary, or you can simplify it, rationalize this product, and create an optimal product model, right? One example is probably mobile handset with different colors, different storage options there. So if you go into considering modeling each headset with different colors, different colors, different storage options per product, then you will basically land up into multiple permutation combination of these mobile products, which will load your catalog, which will create number of products into your catalog, and basically load up your even CPQ APIs as well. Avoid modeling products to make order capture look better, such as introducing a hierarchy just to collapse available product option. For guided selling flows, minimize attribute capture and use default values and overrides to improve the accuracy of order capture. Limit custom implementation to when necessary. Code heavy implementation will lead to longer release time, and technical debt will slow innovation. Right. So basically, to summarize, you should focus on simplifying your product model as much as possible. Try to rationalize, right? Avoid modeling products just to make your order capture look better. Just introducing several hierarchy levels just to collapse or expand the levels. So all these factors would result into your performance issues, scalability issues. So you should all consider all these factors while when you design your product model. Another factor is to consider is asset migration. If you are in a situation where you have customers which have a quite big legacy system, there are a lot of assets. They have their legacy products modeled into some different system. So when you start your migration, asset migration, when you are bringing all these assets, you have to map all your legacy products to your to the products which are defined in the SFI, right? So it is very important to consider this aspect, how the products are defined in the legacy, how you can rationalize them, optimize them, how you map them into Salesforce system. So there are very some of the example questions which I could think of are you can ask during defining this model, like who who owns the data, where does my source data live, do I have access to my data, what format is my data in, Do I need to clean or deduplicate my data? How much data do I have? What data is actually required? What is the production date? So all these factors would impact your product modeling as well. Make the considerations also very important because you will not run only provide orders, right? Your customers would want to have your changes to their product, changes to their assets. So you should consider when different aspects of the order, like new provide, then change order, and all make these scenarios basically move, amend, cancel, uh, and disconnect, right? So based on all these move, add, change, delete scenario, basically will impact your product modeling as well. So you should consider these make these scenarios, and run through the process for all the MACDs while you're designing your product model. Think downstream. What I mean by downstream is your order management system, your downstream systems, which are integrated or which for or which will be integrated to SFI Comms Cloud. So your SFI communication cloud may or may not include order management. If so, consider the technical catalog model as early as possible in design. Modeling in SFI order management, begins with design time configuration that result into uh, dynamic workflows to fulfill the products, service, and resource defined on the orders. The process of order management basically leads to creating your decomposition, creating your service order, and then all the service orders goes into fulfillment aspect through orchestration, and then uh, all these commercial products will basically eventually turn into an asset for the customer. And this occurs when the product is being provisioned and external system must be contacted to book or provision the product. So the assetization process is basically, creates, updates, or delete assets and technical inventory item. Technical inventory items are basically, you know, are your service inventories, or a realization of your customer facing services and product resource facing services. Just like assets are realization of commercial products. So you can understand technical inventory like your commercial product, your broadband, let's say broadband fiber plan will turn into an asset which is a commercial offer. Similarly, under where the broadband offer is decomposed, like your billing CFS or your resource RFS will convert in or will realized into an technical or technical inventories. Another important aspect of to consider when you are considering your product modeling design, what type of pricing is needed, right? There are different pricing patterns involved in SFI. One is fixed pricing, which is most often used. Uh, Basically, a charge can be one time or it could be a recurring amount. Regardless of service configuration or the configuration, basically it is independent. It doesn't depend on any condition. Whatever configuration you do, the price will remain fixed, right? Conditional pricing. So conditional pricing basically is a pattern when the price can be one time, or price for a product offering depends on a simple condition. For example, a service provider can include a free cable modem if a customer signs up for a 12 months contract, right? So it's basically a condition when a customer signing up for a 12-month contract, then he will get a free cable, right? Otherwise, the modem is offered. If it is doesn't sign up for a contract, he has to pay. Okay. Another example could be a free shipping or free activation charge for those orders. Conditional pricing can be thought of as the simplest example of attribute-based pricing, which is tailored for complex condition with multiple criteria, right? So it attribute-based pricing basically you when you are configuring your product, you are providing the condition that my product is fiber, this is the speed, and for each you can take an example probably for each speed type your price may vary, right? So there is a condition depending on the speed, and your price is depending on that speed, and you have different prices based on this speed. So this could be a conditional pricing. Promotional pricing basically is you know uh, promotional pricing basically introduced to attract consumers, which basically kind of uh, which kind of used to increase market demand, generate sales, create brand royalty. So probably service provider could introduce several promotions for each type of offerings to basically increase their sales. Promotions here is providing a certain kind of discount on for a limited period of time, uh, and basically these promotions in telco industry are mostly launched during any event, holiday, or for certain time period. Bundle pricing, so bundle pricing basically you will have a bundle which compromises of which holds multiple child products or comprises of um, multiple child products under a single parent. So but you don't have the price for each of the child, rather you will define a price at the root level, which is a top parent level. That is called the bundle price. Example could be, you could have again a fixed broadband product, and for that you have under that you have your modem, then you have your some add-ons under it, which are all priced at zero, but you have your price defined on the root level. Then there is a pattern of custom pricing. There are several service providers, which have unique requirements for each of their product, depending on the several conditions. The pricing may vary, so they might go into a solution which is called customized solution for pricing, to introduce certain conditions which are complex to handle by attribute based pricing. That's where you can go and adapt this pattern of custom pricing. By the way, and this custom pricing is not recommended because it will lead into customizing and developing the code, and it could also impact your performance. So it's not recommended unless your the requirement is not satisfied by the out of the box solution. Product attributes. Attributes basically are characteristics, per TM forum. It can be thought of as a product feature. So you can SFI in enterprise product catalog. It gives you the capability to define all these characteristics on your commercial product, plus on as well as on your technical product. Uh, Basically it's there is no hard and fast rule around what is to be defined as a product or what it needs to be defined as the attribute. It depends on many things like customer requirement, existing application ecosystem, your downstream system. But you should consider your end-to-end design, gather your requirements, then basically analyze and see whether you really need to build a product, or you can have it modeled as an attribute. An example, we can take an example of modeling paradigm. Basically what art and science behind what type of pattern, what type of options of product models are available. So this is an example of an iPhone model, basically available in the colors of silver, space, and silver space gray, and with two memory sizes, 64 GB and 256 GB. So how you can model this requirement? Option one, you can have one record for iPhone X, and then basically you define the attributes. You define manufacturer, uh, who is the company who manufacture this, Apple, for example, Apple, what type of model it is, color and capacity. All this goes into an attribute, and then you have basically your prices defined on based on any of the attribute you have configured. Option two could be you basically go with for each model type, you create an separate product. So you land up into three records, but you have attributes for color and capacity. Option three could be you basically define your memory sizes as well as memory size as a product. So Apple iPhone X 64 GB would be now a product. Then Apple iPhone X 256 GB would result into another product, right? And then option four, basically you are modeling each color as also, and basically you do not define any attribute, and you just go and create products for all the characteristics. So you have Apple iPhone X 64 GB, then which is silver, then you have iPhone X 256 GB with silver, then iPhone X 64 GB with space gray, 256 GB with space gray. So you will create all number of permutation combination based on the option four, right? So which will end up into option four basically will end up into several products in your catalog. So it is advised, from SFA side, we recommend to create basically option create your model, your product based on option one. But there could be requirements dependency based on uh, a downstream system, or there could be a several business constraint, and so you might have to land up into probably option two, three, or four as well. But the recommendation is always go with option one. Try to again, the concept is try to rationalize and try to optimize, simplify. So product to SKU solution again, resolution. Sorry, an example again. A typical telco equipment model comes in a variant of features that leads to an explosion of SKUs that needs to be modeled to account for order capture, inventory, billing, and many other purposes, right? So iPhone X models. Basically, you have let's say three models. Then you have uh, two colors, then you have two memory storage, right? So based on this, you would say, let's say three in three multiplied by two colors, and then again multiplied by two storage types, it would land up into 12 SKUs. And this is just remember, just this is for one iPhone, right? And the number will grow exponentially as the number of attributes and the values that need supporting increases, right? So you will basically, if you go by this, you will end up into thousands, or hundreds of thousands of SKUs. So if the important point to note here is, you should not uh, uh, because again SKU is again a technical requirement for the product, right? Customer doesn't needs to know what type of SKU or what SKU is used for silver color or space color or different memory sizes. What information he needs, what type of information, what type of color iPhone is available for, and what are the memory sizes, and probably a model. He or she doesn't need to know that what SKU is mapped for each color or each memory sizes. So you should not, while you are designing your product model, you should not consider all this technical requirement to present to the customer. If you go by this, you will end up into thousands of products. So how to what kind of approach you can take? Basically, possible options could be using attribute based pricing, create additional output if you want to really want to map, right, these SKUs, because this is nothing, just the technical information which needs to be sent down to downstream system for basically inventory knockoff, or have the report generated for inventories, hardware inventories. So you can, one option could be, you can basically have this information stored in additional your calculation matrices column. Also, if you want to create a custom object to just maintain the SKU mapping, and you can use this uh, SKU mapping from many metrics, or custom object, and map it during your order management callouts, or auto tasks, that you can basically for each model or each memory size or color, you can basically retrieve the SKUs from your custom object or matrix and then map it into that service order. Product attributes modeling. Basically, we always recommend to start configuring your attribute based on object type. So you should define first. You should start defining the object type for SFI provides the capability to define your object types hierarchically, and it basically use the concept of inheritance. So basically, if you define a hierarchy, the child will inherit the attributes or characteristics from its parents, right? So don't define your attributes directly on the product. Try to create your object type model, define your attributes against each object type, and then assign this object type to the product. So whatever object type you assign to the product will inherit these all attributes, and you would be able to see all these attributes on the product. So example of attributes could be your, brand, size, data speed, credit check, USB ports. Then under apart from product attributes, there are default fields which comes on this object type. Basically, you can see on product to object, there would be some certain or predefined field available, such as name, product code, status, which comes with the solution by default. How you should model your attribute as well. Like I was explaining, you should maintain a pure product specification as much as possible. Product details that supports the ordering of the product, or I would say a commercial side of the product, kept to minimum in EPC, and strive to model this data outside of EPC. So you should only uh, capture attributes which are relevant for customer and actually needed in the EPC. If there is any extra information or any other information needed, you should keep these information outside of the EPC. You should not model this information on the product. Keep it on order item, order, or any other object, right? Product supporting data can be modeled, like I was explaining. You can model this information order line item, or any other standard Salesforce object. It doesn't needs to be necessarily modeled. Everything need not to be captured on the product. If you try to capture all the information as a product attribute, again you will end up into having tens and multiples of attribute on the product, which will slow down your journey for selling the product. Plus it will also load the product and create several scalability, maintenance, or performance issues. So what could be the categories of issue? There could be pricing attributes, where attributes which are impacting your prices for the product. uh, Provisioning information, which is also, by the way, could be required by customers, such as download speed, upload speed, but not needed for pricing. Right? Provisioning information, which is actually technical information which is needed by downstream system or your networking system, and need not to be presented on the commercial product. So these kind of attributes could be modeled on the technical products. Similarly, service information from downstream. So there could be scenarios where some information is coming back from the provisioning system on the technical product or commercial product. So some such kind of attributes could be categorized into service information, which for which the information will be flown down from the in provisioning system to SFI. So here is an example of technical data. Uh, you could see, there are number of portability check was made as part of the order capture journey. This supporting data is required to be passed to the downstream system. And there was, so all this, if you could see the list, this was, a portability check was done, and all this information was coming back from our external system, right? And all this information need not to be mapped to the commercial product because it is not relevant to the customer, and this is not relevant to even product as well, right? This information is relevant to whether the customer is available for portability or not, right? So what solution was adopted, that this information was uh, returned in a JSON form and was captured on the order item in form of JSON attribute, so that you can have your key value pair mapping, and it could be utilized later in the order management stage. Independent products. What are these independent products? Uh, Basically, you when there will be requirements presented to you for design the product model, you should identify such products which are not dependent on each other or not dependent of any other products. Those are basically their life cycle is independent, and they you can add them, remove them independent of any other product. Some of the example could be, activation fee, delivery fee. There could be a product like Microsoft Office, which doesn't need to be dependent on any other product. It could be configured independently. There are some examples like I explained: activation charge, shipping charge, installation charge, penalty charges. These kind of products can be modeled independent of your bundle or any other product. What kind of performance consideration you should think of while you are designing or developing your product model? So very important to note, just focus on these points when you are designing, or consider these points when you are designing your product model. First one is depth of the offer has a major impact on CPU performance. The bigger the hierarchy is, the higher the performance impact is. It will Big bundles will create a lot of issues in loading, first of loading into the cart, adding all this product into the cart, then running the pricing. So we don't recommend to go beyond four levels of hierarchy. Try to limit or keep your hierarchy level as minimum as possible. Our recommendation is 4 levels. You can go up to 4 levels, but don't go beyond it. Uh, deep, as I was explaining this will deep hierarchy will significantly impact your API performance. Uh, what we usually recommend is, instead of creating multiple products or multiple levels of hierarchy, try to see uh, whether you can leverage the capability of modeling some products as an attribute. uh, uh, whether it makes sense to model them as an attribute based on the business view or business standpoint. uh, so you should consider all these factors while you're designing. Then, what are commercial attributes, what are your technical. You should, again, I would emphasize on separating these commercial and technical catalog, which would make your life easier while you're doing your product models, and it will uh, prevent unnecessary handling of technical information at during the commercial ordering process. You should not depend on how the product is displayed on the UI, right? So UI should not come and dictate the requirement that the information or the product should look like on this or look like in this way, X way or Y way. Rather, you should focus on modeling the product as optimal, simplified, which would you know uh, simplify your guided selling process, have your give you the capability of scaling this product, scaling your performance, and just not focus on visual representation. You should also consider your MACD scenarios, your assetization, sorry, not assetization, asset migration, uh, for product modeling concept. If you want, if you want to group the products, you can use. There is a capability of having virtual products where, like, there are roaming add-ons, right? There could be several roaming add-ons, and you want to group them into one category. You can have defined a virtual product as roaming categories, and define your roaming products under it, rather than just creating a parent product of for just for logical grouping. Now, coming to context rules and advanced rules. Velocity basically have two rules frameworks. One is context rules and another is advanced rules. Use contextual frameworks to determine what products, promotions, and prices appear in velocity card. You can basically specify when to apply a penalty for cancellation and what the penalty will be through the contextual framework. Right. Then with advanced rule framework, you should use them to define the product compatibility rules based on condition in order line items and related objects. You can also create advanced pricing, availability, and eligibility rules. But we for availability and eligibility, we recommend to go via contextual framework because those are lighter. And for compatibility rules, our recommendation is to use advanced. You can use rules to change standard product and pricing behavior in velocity card. Velocity rules are essential to create the perfect order. So there, in telco world, wherever you go, there will be definitely business rules will be presented to you to configure it, and you have to decide what type of rules I have to do for the each business requirement. Whether it should be go into configured as a context rule or it should be modeled as an advanced rule. So we have basically a matrix defined, which will be coming into the next slide. to make your decision easy, what type to use and when. And these context rule and advanced rule frameworks work together, because one would decide your eligibility criteria, advanced rule will decide on your compatibility between the product. uh, so you must determine what type of rules to use to accomplish your business requirements. Always, our recommendation is always go with context rules unless any key functionality is not supported, like compatibility thing. If there is no compatibility requirement of like auto add, auto remove, then you can basically stick to context rules. Uh, so basically, as I explained, these are the two separate frameworks, and have supports different functionality. So it is really important to understand the differences between these two rules frameworks to determine what would be best to suit your requirement. Okay. What will the rule apply to? Okay, so what objects will the rule apply to? Will it be used to determine eligibility for a product or promotion? Will it apply pricing? Will it apply a penalty when canceling a promotion or a contract? So based on this object, you can say this is a table which give you which will help you to make your decision. What rules are supported on which object, like context rules and advanced rules both are supported on product, but you can see for promotions only context rules are supported, advanced rules are not supported. So you have to through this guiding principles you have to make your decision, uh, that what type of rules I would need for on what stage. Basically, for object or on this table, you could see what type of objects is supporting what type of rules. Next would be at what stage which rule would be supported. So, for example, on order stage, you would support context rules and advanced rules both. Course, opportunity, all all three would support both contextual and advanced rule. But when it comes to a order line item, when you add these uh, uh, any product to basket or cart, context rules will not be supported in the basket or cart context. Only advanced rule will be supported. So you have to go by this table when you are defining your rules, and you should decide based on these matrices what type, which rule will suit my requirement. Third metrics would be, why do you need this rule? Do you need a compatibility check? Whether you want to have, you want to do a eligibility check based on the geography or zip code basis, or your address basis, or do you need to apply a penalty? Or do you need to weigh multiple prices based on some criteria? So all based on these conditions, based on this requirement, you have to decide which rule I would need, right? So for example, product compatibility, you cannot check via contextual, because product compatibility only will be checked when any product is present in the cart or basket. So in that, only advanced rules are supported to check eligibility, availability. Both type of framework is supported, but we always advise to use context rules, because it is on it works on lighter format. It is you can cache the context dimension values so that it is works quite fast. Similarly, there are other categories, other criterias which will help you to decide what type of rules you would need. Again, how will you manage this rule? How will your administrator manage or administrator manage the rule? Will this rule apply to a single product or thousands of product? Do you need maximum performance? So these all criterias will help you to make your decision. Again, so there are some best practices which or guiding principles which will help you during your implementation, or when you are designing these rules. You should follow these best practices to minimize the number of rules, or to do not make any rules any like heavier. So you should let's go one by one and understand what it is, and how you can follow this. uh, so first is understand your customer requirements end to end before you decide on which type of rule to use. So you should have your clear requirement. You should ask your customer, define the requirements clearly, and end to end, so that you can decide on what type of rules you can use. Consider reviewing business process and related requirements to reduce rule complexity. So uh, you should see the requirements, whether you can introduce a business processes, or you can optimize the business processes, which through reviewing this business processes or related requirement, you could avoid creating additional rules or unnecessary rules which could be handled by a process. Ensure all active rules are not missing configurations. There are scenarios, where probably you created rules, uh, and those are active, but you basically don't have any entity filter condition defined, or any other conditions defined under this rules, but this rule is active. So what happens whenever a CPQ API is fired, this rule, it will check this rule is active, and it will fire this rule, and again evaluate. It will see whether an entity filter is present or not. So this will utilize your CPQ resources and slow down your performance. Whenever possible, leverage the capability of cardinalities and override functionality instead of just creating advanced rules. So there could be, for example, there could be scenarios where you want to exclude a product for certain bundle, or include a product in a certain bundle. So instead of creating a rule to auto add or auto remove the product, you could just simply have the cardinality override functionality. Basically, you can define based on each bundle what type of you can use group cardinalities to define this functionality, what products are available under the bundle and what are not. For performance consideration, as I was explaining, it is recommended to use context rules instead of advanced rules for penalties. When possible, consider grouping rules using common entities. Uh, Keep entity filters conditions to an optimized number. We recommend max to keep it to two. I have seen implementations which creates conditions for like six or seven entity filter conditions. And when it comes to, you can imagine, like if you have six or seven conditions to evaluate a single product, if you have like 10 order line items on in your card or the basket, this rule or this entity filter will be evaluated against each product, and it will heavily impact the performance, and sometime it will hit the governor limit, and it will your transaction will result into epic CPU timeout, and your order would result into failure, which will not be a good experience to the customer. So always remember to have it optimized. Avoid creating too many auto add or auto remove rules, because each rules will be fired or validated against whenever the APIs are invoked. Okay, instead try to leverage the cardinalities and overrides. Ensuring you have enabled cacheable mode, and have your have populated values for caching and default values for context dimension to cache eligibility combination. So when you define the context role, and before defining the context rule, you have to define the cache, context dimensions, which which gives you an option to load it into a cache, so that each time there will not be any query to the database to basically check what type of context dimension it is. It will be cached, and it will that whenever the APIs are called, this data will be loaded from the cache. Avoid user specific logic, right? For particular users, you want to have certain rules defined for context rules based on the content data, which will it will result into a number of rules, again would result into performance issue. Avoid writing rules for each and every business scenario, right? Try to handle it with with product modeling, with your business processes defined. So uh, eventually you'll end up creating basically optimized number of rules, or lower number of rules, which are essential for, or essential business rules for the transaction, and not like rules for even evaluating a small conditions. With that, we should go to modeling patterns to discuss what type of modeling patterns we have available under the SFI. So the first pattern is hierarchical pattern, which mostly we call it in regular language is a bundle product. Basically, you have a root product, a parent product, and under that you have several child product defined uh, under the root product. And there would be two options: whether you define the price at the root level, or you have prices defined on each level, and those prices rolled up to the root. Okay. When these pattern should be followed, or when this pattern should be, depends on the requirements, right? uh, Normally I've seen that this pattern is mostly used for fiber, when you have bundle of triple play, quad play, or when you have uh, you want to model two different products together. Let's say you want to offer broadband and TV together, so you will join this product in a bundle, and you have the price defined against them. So also with this, you will have some pros and cons. Basically, pros will be you will efficiently manage the cardinality requirement without using advanced rules such as minimum, max, default cardinality, and group cardinality. Define reusable components across different EPC bundles, saving time and off loading the maintenance efforts. uh, Cardinality requirements of product bundle components are easily satisfied in a hierarchical product structure. So basically, like I was giving an example earlier, that you could use cardinalities under a bundle to define whether the product is available under a set under one bundle, and not available under another bundle. So you can have these advantages, and if you are using a bundle product, and there are sometimes requirement also for from the business side, that they want to sell these offerings together, right? Due to some promotions, due to some other business criteria. Cons, the front end application of order capture needs to render the complete product hierarchy of mandatory as well as optional add-on child product. So in case of you have your self service portal, you have the API needs to fetch all the probably full hierarchy of that bundle, so that you have all the options defined on the UI, that under the bundle, that what are the mandatory products under this bundle which will be added automatically, and what are the optional product which needs to be added under this bundle. Second modeling pattern is, offer meiosis pattern. Basically, this is mostly used when you have, uh, two similar type of offerings, and this is mostly used when you have your, change of plan scenario, where basically there are two type of bundle under could be a same offering, but there could be a possibility that one, let's say, bundle commercial offer one has only one child product or one add-on, but commercial offer two has, two add-ons. So in such cases, rest of the characteristics, everything is same. The offering is same. So in this case, what could also price could also be a different, but underlying characteristics, technical characteristics, commercial characteristics are all same, are all same. So what you, in that case, what it basically gives you an advantage when you are doing offer migration or change of plan. So basically, it gives you, defining this kind of model gives you the flexibility when you introduce a change of plan. So basically, you want to move from, let's say, fiber 100 to fiber 200, right? So it underlying technology is same, underlying characteristics are same. It just there are some hierarchical or product, of changes between these two bundles. So for that purpose, you can use this kind of modeling patterns. And there are some consideration. Uh, the offer message could mix the linear and hierarchical patterns. This mix is different pattern because it represents a different and distinct modeling option compared to the linear, hierarchical, or attribute-based pattern. Carefully evaluate how the model is applied and used during the MACD scenarios. EPC architect should carefully evaluate how this model is applied and used during the MACD scenarios to avoid creating bulky orders. Hierarchical representation doesn't represent catalog categories. Hierarchical structure should omit any product used to represent service fees such as shipping fee, installation. Like we discussed, these products could be modeled as independent products and should not be considered under this. Uh, what are the pros and cons? Let's try to understand of this for this pattern. It's the best available pattern to represent the availability of multiple exclusive offers with diverging configurations, right? It provides an accurate and detailed representation of the actions and changes performed by the MACD process while moving from a source to target offer. So, like I was explaining, when you do offer migration or change of plan in the MACD process, it will clearly depict that what changes, what offer is getting added, what is getting disconnected, what changes is been made. So this will be clearly captured on this. Uh, so this major advantage you will see on order management side, which will have clear order actions list, what uh, for each order line item, what are the actions. End user, it gives a clear functional understanding, what type of characteristics I am currently holding, what type of offer I am currently on, and which offer I would be moving to, and what are the components included under the target offer. Cons are that these are like bundle transaction. These two are bundled offers. There could be multiple line item under this single bundle, and when you are moving from one bundle to another bundle, this could be a heavy transaction again, because there would be several actions performed based on your old offering would have some disconnect offers, and your new offering will have add, and there would be new rules on the offers as well. So this transaction could be heavier. And these two different offers, when you are moving from source to target, it will not support the inheritance of promotions and discounts during the change of plan process. So basically, if you are enjoying some discount on offer A, and but now you want to, let's say, upgrade and move to offer B, your discounts and promotion will not be carried over to offer B, but there could be new promotions applied to to offer B, right? So it will all your existing pricing, your existing promotion discounts will not be moving to your new offer target or probably target offer. It will, it, but your target offer can have a new promotion, new discount applied to it. Uh, So third pattern is your relies on basically your or linear modeling. This is linear pattern is an option when the following conditions are met. Basically, the new item is not requested to be represented as hierarchically related to another commercial offer. There is no dependency between hard dependency between these offering. The item is not requested to have different price or cardinality rules based on other commercial offer. Uh, so the number of advanced rules or relationships managed are limited, right? So then you can use the linear modeling approach. Uh, Consideration for limited cardinality rules or product relationship, the same model may be applied by relying on some product capabilities such as the following: advanced rules, auto add, auto remove, requires, exclude. So what basically tries to say that you can have a relies on relationship between those. You can define your offer A and offer B separately. And that I mean, these two offers don't need to be necessarily dependent on each other or hard linked. It could be independent offers, and you can create a relies on record or relies on product relationship between these two offers, right? And this product relationship, and there could be requirement on how this relies on relationship should be managed. So you can manage via your product relationship or advanced rules like requires, exclude, recommend, auto add, or remove, requires, exclude. And normally in some implementations where you want to there are business requirements to keep your product modeling linear to have probably to gain some performance improvements uh, on CPQ side. You can use this linear modeling approach, and where and also in terms of B2B cases also, there you will face you will have this kind of requirement quite frequently, because there are in B2B spaces there are complex products, and you will have requirements such as products which SD-WAN, IPVPN, which would have probably shared access, and these two relies on some common products. So in such scenarios, you can use relies on pattern. Also, what are the pros and cons against relies on? It basically reduces the number of order item managed during the sales. So the advantage is when you are adding a product, it is not a bundle. So basically you will be adding a single product in a single transaction or single API. And even in your MACD transactions also, these as you have modeled your product linearly. When you perform a MACD, you will have only that single product carried over, or carried over to a cart or basket, uh, and not opposite to the bundle. Like in bundle cases, the whole bundle would be, even you want to change a single characteristic or single product in the bundle, the whole bundle will be moved to the cart, and then you have to change that product or individual characteristic under that bundle. But in linear product, this give you the flexibility. Let's say you have four linear products each, a couple of them relies on a single product. So then you can basically bring a single product into the card and change particularly for that product. And you don't have to bring all the products or all the assets into the card to just change to make a change. It supports the capability to use eligibility rules to enable or disable the selection of the product, supports the capability to show the product price before it's added to the cart, and provides a better user experience while searching or browsing the catalog than the hierarchical pattern. So basically, just to give you an example, if there, if you are you have configured your offers as a bundle, then the price will be visible only on the top level offer, the bundle offer, which you would be able to see the price. But the optional product which are present under the bundle, until unless you add those product into the cart, the prices will not be visible on the cart. So for the customers, it would be still you have to either do some fetch the prices explicitly from the catalog for these offers and display on the UI, or you have to add these offers to know the prices for them, right? And opposite to this, in linear modeling, you will have prices configured under for each individual product, and you don't have to query the prices. Once you do query or you run the get products, it will basically by default it will return the prices, and you can show these prices on the self-service portals, which will be clearly visible and more transparent to customer. Uh, Yeah, another benefit is performance gain on the APIs, because now instead of bundle you have to deal with only single products in single transaction, where, compared to the bundle, because in bundle you could land up into four line items under a bundle, and each line item will be run against pricing validations and uh, um, uh, uh, other criteria to check. But in single product, there will be only whenever you do any modification, you perform any changes to this product, or you add this product, only the whole transaction pricing validation would run against the single product, right? So generally, the performance would be better in terms of linear products. Cons would be, again, there is no possibility to represent any hierarchical relationship. Uh, Too complex or too many advanced rules might, because you now have to, create dependencies, manage those dependencies. So you might have to, in linear modeling, you might have to manage all these dependencies through advanced rules. So your rules might increase in such modeling, and which could create some performance issues or and maintenance issue. So attributes, the last pattern is attribute based, right? So as I was explaining earlier in our product modeling best practices, that not each characteristics or a business requirement needs to be modeled as a product, right? We have seen the example of iPhone X, where you have colors, memory sizes, and you will end up into a lot of permutation combination. So you could, rather than going into modeling each characteristic into any product, you could basically define an attribute based model. You can have a product and then define characteristics or attributes against this product, and you can use the capability of attribute based pricing. If you have if you have your conditional pricing, or you can use fixed pricing approach pattern as well. Depends on the business requirement. Again, the attribute based model will give you again the flexibility of managing your technical and commercial products separately. You can define the technical attributes on technical products separately. Then you have your commercial attributes defined on commercial product, which gives you, which maps these two commercial and technical aspects separately. And it is easy for even maintenance also. uh, and it gives you more flexibility to, rather than going through for each product life cycle, you have to just make the changes on the attribute level. Pros and cons, that it reduces, as I explained, it reduces the number of borderline items added to the cart, or it also reduces your catalog size significantly, because now you are you are dealing with attributes on the products and not modeling each attribute as a product. uh, it will also reduce your payload size and complexities of CPQ APIs, especially when you have your V2 attribute model V2 attribute model enabled. Uh, just to give you a short intro on, because I mentioned V2 attribute model. So whoever is not aware of V2 attribute model, basically in SFI you have two type of attribute, V1 and V2. V1 attribute model had very big JSON which caused issues during the performance of API. So now we have V2 attribute model, which is just a shorter version of JSON and only a runtime and default attributes which are used on the product. Those are mapped on these order line item, and it's a very short JSON. Only have key value pair mapping. So this will again give you some performance benefits when you have defined attributes. Cons could be, you cannot, not can, probably when you define your eligibility criteria based on the attribute, it could land up into, some customization, because it's not easy to just define some context rule or advanced rule on attribute. You have to probably eligibility specifically on, context rule side, you have to create some customization to evaluate these attribute values. Attributes are generally, more complex to read and change from digital commerce and card-based API perspective. Attributes do not support both eligibility and advanced rules, such as these product relationship like auto add, auto remove, required, excludes. It's only for attributes you can only do a modified attribute kind of product relationship, which allows you to basically assign any or override any attribute value. So let's discuss some example of of some product models and how you could optimize that. So this is the one example of a product model which was created for one of the Comms Cloud customer. Uh, you could see that this is a bundled offering. You can see there are variations based on the speed of the product, and how you can transform into, or how you can rationalize or optimize this product model into a recommended one, or a product model which is following the best practices. So you could see this parent mobile offer becomes it becomes your product offer. Then you have just simple a child product under it, and all your data variations becomes attribute. And if you have prices against each of these products, you can basically configure attribute based pricing in your calculation matrix, and you can run the pricing against the each selected values, right? Issues under this product model, if you have kind of bundled big deep hierarchy product model, what kind of issues you will have. One issue is deep. There is a deep product hierarchy. This makes product bundle heavy and cause API performance issue. Uh, you have unnecessarily created each data volume as a product rather than just utilizing the attribute. It could generate this kind of model could have a heavy payload because there are a number of products involved in this, and could land up into heavy JSON, and uh, which would create a scalability of API performance issues. What benefits it give, you can see the model is quite simplified. It gives you flexibility of maintaining this model. It's lesser number of products. It's a light payload, and it gives you capability to price this product differently against based on the attribute value. Let's take another example. Similarly, if you see here, again, this is a quite big bundle, and if you can see, if I have to load all these line items into a cart, how heavy the API transaction would become, or how heavy the payload would become. Instead of it, we can go on, again, it depends on the business requirement, but the recommended approach or suggested product model is to basically follow the configure the attributes, follow the attribute based model, and go over define. Basically, it's kind of a balanced model between bundle, attribute based, right? So you could create a small bundle, but you can identify some of the products which are which can be converted into the attribute, so that you don't have a long list or a number of products under this single parent. You could transform them into an attribute and use basically attribute based pricing. So similar issues we will face in this type of product modeling, that it is again lined up into deep hierarchy and number of products. You have modeled some of the technical information on your commercial product, which is not relevant for the customer, and it will again slow down your API performances. Against the benefit, on the suggested product model, again, we have reduced the number of products significantly. We are using attribute based model, attribute based pricing. So uh, with the point is, for this example is, you should identify such kind of patterns, what would be beneficial for the implementation, and agreeable by the business stakeholder. So you have to make a balance between between your product model and the business requirements. Now coming to the product lifecycle changes, how product what kind of changes are performed on the product, and what are the risk criteria, whether it is low risk or high risk. So as explained here, you could see that if you are making changes into a prices, or name changes, or any update on the rule, or adding a promotion, it could be considered as a low to medium risk assessment, versus when you are basically changing the complete pricing logic, or you are introducing a new product, you are basically changing a hierarchy of the bundle, or you are removing a child product from a bundle. So this could be considered as a high risk changes, and needs to be tested properly before deploying to the production. This is the metrics again to help you to identify what kind of pattern you could follow, what kind of pattern is supported. So you can go through all this list, which will help you to determine the pattern you want to follow. Uh, with this, I would like to wrap up this product modeling session. And again, I would like to thank you, ApexArs, to provide me this opportunity to share the knowledge and best practices followed for EPC. Thank you very much.